Good evening, everyone. Good to be with you. As Don has suggested in his introduction, when Paul the Apostle preached the Christian gospel in the university city of Athens, he began by proclaiming the God of the Bible to be the Creator. And he ended by proclaiming the resurrection of Jesus Christ from the dead. And that's pretty much the plan that I want to follow this evening. Paul was preaching in a place where the Greek culture and politics was held sway, and of course very much the Greek culture and politics is still with us today. We have democracy, which is a Greek invention, and the elevation of the arts and sciences very much following the Greek pattern. And so, standing against that pattern, the Bible, and recording Paul the Apostle, proclaims then the Creator, God, as the foundation of all things. And we may tend to think of creation as just something concerned with the first couple of chapters of the book of Genesis, but in fact it goes through the whole of the Bible record. And in the book of Jeremiah we have these words. This is God speaking, as it were, through the prophet, saying that he has made the earth, he's made the beast upon the ground by his power, and given it to whom it seemed proper to him. So there's just one of many claims in the Bible that God is the creator of all things. Interestingly, that statement, the context of that statement in Jeremiah chapter 27 is a prophecy concerning the coming of concerning the coming of Nebuchadnezzar, the king of Babylon, to capture Jerusalem and take the Jewish people into exile because of their disobedience to God. And that happened. Jeremiah was a prophet, and through the power of God he foretold the future, and it happened. Now there's a very powerful demonstration that the Bible is the Word of God, because God is able alone to know the future and predict it. We, as Christadelphians, believe in the God of the Bible, and that is a matter of faith. Believe is just another word for faith. And I thought very briefly, I'd like to just put before you 5 reasons for our faith. I'm not suggesting they're the only ones, because of course it's become quite notorious these days to speak of faith as blind faith, as believing in something for which there is no evidence and which cannot be proved, and you'll know who I'm quoting there. So what evidence is there? If we begin with science, which is supposed to have made the Bible out of date and irrelevant, one of the things that has been shown by science above all is the design and the complexity of the universe. And many scientists, not particularly religious, have pointed to the astonishing way in which the fundamental forces of the universe are exquisitely balanced to make the universe suitable for life. Just one example, the ground state energy of the carbon atom. If it was 1% either side of its value, it would make organic compounds consisting of chains of carbon atoms impossible. And all life as we understand it is based upon carbon molecules. So that's just one example out of many. That the fundamental physics of the universe seems to be fine-tuned to be favourable for life. Now, accepting that there is a God, it seems to me, and perhaps to you, wholly reasonable to think that he would want to communicate with the only rational, intelligent being on the planet, which is mankind. Not suggesting Many of the animals are very intelligent, but they don't have the ability of rational thought and to know something much greater than themselves. And we believe that the Bible makes a valid claim to be a record, a message from the God of heaven. And some of the reasons to think that, I've already intimated one, and that is the fulfilment of prophecy. I've already hinted at Professor Dawkins. I should probably use his name a number of times this evening, because the opposition to the Bible from science is sort of focused. He's the most vocal voice. In his book, The God Delusion, he does not mention the fulfilment of prophecy. And we believe that's a very powerful proof that God exists and that the Bible is a message from him. The futures of many of the nations of the Middle East which were around Israel, the chosen people in the Old Testament, their futures were detailed in outlined in great detail, and have to this day been shown to be true. But above all, there is the history of the unique nation, God's witnesses as they are declared to be by the prophet Isaiah. And the prophets foretold a long period of exile from their land for the Jewish people and a regathering in the last days. Now, you cannot deny that that has taken place. 60 years ago, there was no nation of Israel. Then the nation of Israel was born. It was proclaimed at United Nations. It's a significant nation in the world today. And we believe that is a herald of great events yet to come. And out of the nation of Israel, the unique nation, there is the unique man, the unique Jew, Jesus Christ, the Son of God. And his life is detailed in the Old Testament scriptures, written before he was born. Born of a virgin, born in Bethlehem, born of the tribe of Judah, born to be rejected by his own people, born to be put to death by crucifixion. It's all there in Psalm 22, a detailed description of crucifixion, which hadn't even been invented when the psalm was penned by David 1,000 years before Christ. So these things are powerful, and they, if you don't believe in God, if you don't believe the Bible is his message, then you need to answer the challenge of those facts. So those are just some of the reasons that we believe in God and in his book, the Bible. And the Bible proclaims, as I've already said, as you all know, that God created the heavens and the earth. That's how it begins. Paul the Apostle, in the first century, proclaiming the same fact, beginning his preaching of the gospel with that same fact. And as we've already hinted, the future of the earth is to be filled with God's glory, as the waters cover the sea. You perhaps know the phrase. And so it says that life is there for a purpose. And that stands over against the idea of modern science that life is just the result of chance mutations. So we have really two worldviews. We have the worldview that says there is a creator, he has communicated with mankind, he has a purpose for the future. And there is the worldview which says that life came about by random chance and therefore cannot have a purpose. I mean, read books on evolution. Evolution has no foreknowledge. It doesn't know where it's going. It goes wherever chance mutations direct it. So there is the other worldview. Some try to ally the two to bring together God and evolution, and it's generally termed theistic evolution. We'll think about that perhaps a little later. That's some sort of compromise position. So the scientific view which is particularly propounded in the media, on the BBC. We get the wonderful, the marvellous TV programmes, Dr. Attenborough and so on, which have presented to us the marvels of the world in which we live. And we are a privileged generation, aren't we? We've seen things that no previous generation has seen. The intricacy and the marvel of life in all its forms. On the earth, in distant parts of the earth, under the sea. And we've been brought, all those have been brought before us, but presented as the result of the evolutionary process. So the philosophy of the age is naturalism. We cannot explain anything except by natural processes which can be seen acting now and which can be carried out in the laboratory. So ultimately there cannot be a purpose. Life has no purpose, and Professor Dawkins proclaims that loud and clear. Now, before we go on, we just need to define what we mean by evolution, because evolution has become a paradigm that's used in all sorts of contexts. I mean, people talk about evolution quite away from biology. You might talk about the evolution of the motor car, and you can go to the Transport Museum in Coventry and see those wonderful old machines, 100 years old, and then follow through to the gleaming, streamlined things of today. You could say that's evolved. Interestingly, of course, that has happened because lots of clever scientists and engineers have made it happen. It hasn't happened by chance. So constantly we get the word evolution presented to us, particularly in the field of biology, and so we're told that things have evolved. Very often we're told that without any explanation of how they've evolved, because nobody knows. These things happened in the distant past. So it's important to realise that the word evolution is used in a number of different ways. The basic way it's used is to talk about variations, changes. And none of us can have any quarrel with that. Changes in living things take place all the time. And they're observed, and they've been referred to as microevolution. And so the famous Darwin's finches in the Galapagos Islands, which was one of the observations that set him off on the origin of species, on the different islands in different ecological niches, he observed different beak shapes. He didn't realise they were different species when he brought the samples back to England and they were sent to the Natural History Museum. The taxonomists, the men who decide what's a species and what isn't, they came up originally with 23 different species of these birds from the Galapagos. Today, if you look on the internet, you'll find different. I found 12 different ones, 13 different ones, 14 and 15. So taxonomists never agree, of course. Interestingly, it's been shown in recent years, a great deal of study has been done on the finches, that the change in the expression of a single gene affects the structure of the beaks. They are referred to as different species, and yet again they have been observed on occasions to interbreed. Now, the definition of a species is supposed to be that they're not interbreeding. So one wonders if they are truly separate species. So we have no quarrel with that sort of idea. Now, the theory of evolution, the modern theory, which is called neo-Darwinism, says that the development of completely new creatures, new plants, new insects, new bacteria, takes place by the accumulation of thousands and thousands of these sorts of small variations over huge periods of time. If you have long enough time, eventually all those little changes will add up to big changes. And that's where we start to differ. Because the development of completely new creatures, completely new organs, completely new body plans, by the slow accumulation of changes, has never been observed. By definition, it takes enormous times. And the only supposed evidence for it comes from the fossil record. You cannot carry out experiments in the laboratory to see if it happens. So it is basically, macroevolution is an extrapolation from microevolution that has never been observed. I was astonished a few years ago to read on the BBC News website a report that scientists are excited because they think they may have seen for the first time the beginning of one species diverging into two. And it affects a bird called the greenish warbler, whose area is around the Himalayas. It breeds all the way around the Himalayas. And at the two ends of its range, the birds have different songs. As you go from one end of the range to the other, the song gradually changes. And so at the two ends, they have different songs, and the birds don't interbreed. Now, I would suggest to you that that is no more than this microevolution. It's not a completely new bird or a completely different, hasn't got four wings or developed some completely new structure. It's just a minute change. Now, of course, in the last 50 years or so, with the development of microbiology, when through the development of advanced instrumentation, scientists are able to go down now and see inside the cell and see what makes things happen, and the discovery of DNA, we have a new type of evolution, which is molecular evolution. And ultimately, that takes us right back to the biggest question of all, which is, how did life begin? Now, 50, 60 years ago, a series of experiments were carried out by Professor Muller, and he took gases which are believed to exist on the early Earth, mixtures of gases like methane, hydrogen, and so on, and he put electric sparks through them to simulate lightning, and he found that out of those gases, many of the basic components of life, chemical molecules, were formed, even amino acids, which are the basic building blocks of cells. And there was great excitement. Here is the bridge between non-life, between the basic chemicals of the early Earth and life. Well, 60 years later, that dream has faded, because it's now known that the very simplest forms of life, as single-cell creatures like bacteria, are immensely complex. They have DNA, they have thousands of different proteins inside the cell, they have complexity of an amazing order, and the gulf between non-life and life has just got bigger and bigger. And in spite of many theories, many experiments to try and find a way across, most scientists now say there is no way across that gap. So it is, as I suggested, a mystery. So evolution, as proclaimed by people like Professor Dawkins, is essentially a faith. They don't like being told that, but it is a faith in naturalism, just the operation of the laws of physics and chemistry as a sufficient explanation for all life. Well, the divide between these two approaches to life and the universe, this is a quote from a Nobel Prize winning physiologist, George Wald. He says, this is back in the 60s actually, quote, but it's, I think it's still true today. When it comes to the origin of life, there are only two possibilities: creation or spontaneous generation, life coming from inanimate things. There is no alternative. Well, we all know about the experiments of Pasteur, when he proved that if you kept a broth covered and kept bacteria out, there was no life. Life couldn't just arise out of nothing. And so you only have one alternative left: supernatural creation. Now this is the interesting part. We cannot accept that on philosophical grounds. Therefore, we choose to believe the impossible, that life arose spontaneously by chance. George Waldo, ironically a Jewish-American scientist. And that's still the position today. Evolutionists choose to believe that life has come about by purely natural processes. We choose to believe, we believe on firm rational grounds, that life has come about by the design and the action of the God of heaven. The idea that wherever we look in the living world there is design has been around for a long, long time, but it was first sort of formulated by a classical clergyman naturalist, William Paley, the end of the 18th century, in his book Natural Theology. And he gave the famous example of, if you're out for a walk and you find a watch, you can tell by looking at that it's been designed. There is a difference between a watch and, say, a rock laying on the ground that you might kick against. A rock is just an accidental product of the forces of erosion. A watch has been designed and made by a very clever person. Any watchmakers here this evening? And it's got purpose. I mean, it's got a function to tell the time. And so Paley said the inference is inevitable. The watch must have had a maker. And so he said, when you look at the things of the living world, he says every manifestation of design in the living world exists in the watch. So you look at a flower, and the exquisite design of a flower, quite apart from its beauty, and evolution, I think, is pretty well incapable of explaining beauty. But it's got an intricate arrangement of parts which is designed for a purpose, which is to reproduce the plant and to attract a pollinator, to place the male and female parts of the flower in the right place so that the pollen is lifted off onto the bee's back and it transfers it to another flower. It's all exquisitely designed. So that was Paley's argument. And that essentially was accepted by many of the great scientists of the past. The men who founded modern science thought that they were exploring the works of God. And so famous names from the past of science were all Bible believers. I've put at the bottom John Lennox, you may or may not have heard of. He's the current Professor of Mathematics at Oxford University, so presumably he fairly regularly meets Richard Dawkins in the corridor. And in fact, they've had at least 2 debates, which if you want to follow it up, you can look at them on YouTube and observe their debates. And Lennox's book, God's Undertaker, Has Science Buried God? Is a very, to my mind, very powerful book written from a Bible-believing point of view. So there's a modern man of learning, professor of maths at Oxford, and interestingly he brings a mathematician's view looking at the probability involved in the accumulation of mutations to bring about evolution. Mathematicians are not enthusiasts of neo-Darwinism. Well, that's Paley's argument. Set against that, of course, are the arguments... Oh, I meant to eliminate this thing, so I'll just pass on from that one. Richard Dawkins' book, The Blind Watchmaker, bestseller, still referred to, although it's 30, 40 years old now. And Dawkins said that the watchmaker in nature that designs flowers and so on is natural selection. Natural selection is the driving force of evolution. Now, of course, natural selection alone cannot produce anything new by the very definition. It selects things that already exist. And natural selection requires something else, which is mutation, random changes which take place in cells and which change structures. And that's the neo-Darwinist synthesis. Mutations making new random things, and then natural selection taking the useful ones and perpetuating them. So for Dawkins, natural selection is the blind watchmaker. And he admits very clearly that nature does look as though it's been designed. You know, he would accept that there is design involved in the flower. But he says ultimately that design is the product of natural selection picking out the best bits of the random changes that nature throws up. And what it's saying, of course, is that out of chance processes, random processes, you can produce complex designs. And I should put it to you that that is a faith. This is macroevolution. This is not observed in the living world today. You can only think that it was there in the past. Now, there's an interesting comparison we can make. I don't know how many of you have heard of SETI, the search for extraterrestrial intelligence. That is, looking for aliens or little green men on other worlds. And that search has been going on for over 40 years now. There is a powerful driver for that, of course, because if naturalism has thrown up life on Earth, then it must have done on other planets as well. So there is a great desire to find life on other worlds, to say, well, there you are, life can crop up anywhere, that you don't need a supernatural God. So this search has been going on all those years. So far, they haven't found anything. Now, how would they know? They're looking for radio signals from space, and all the time, random radio signals are coming in, what we call noise. You would have to find something superimposed on the noise that had a definite pattern that said this is intelligent. In the film Contact, science fiction film Contact, the something was a string of prime numbers. You know, the numbers that have got no factors except themselves, like 7, 11, 13 and so on. So if you had a radio signal that suddenly produced a string of prime numbers coming from space, you'd have to say, well, somebody who knows maths is sending that signal. So if you can recognise design when it's coming from outer space, you know, can you not say, well, if you see design on Earth, that must have had the same origin as well? Just something for you to think about. What I want to do now is I'm just going to show you some examples of design in the living which seem to me to be amazing. And you may think they're amazing too. You may think they're easily explainable by natural selection, or that they demand a creator. This is for you to decide. I've just chosen ones that I like. They're random choice. There are thousands of examples of animals, plants, birds, fish, with incredible detailed adaptations for special environments. And it's what I've called the challenge of design. This is a quote from Psalm 104. O Lord, how manifold are your works. In wisdom you have made them all. And for wisdom you could substitute the word design. Design is an intelligent arrangement of parts for a specific purpose. So here's a beautiful bird, very largest seabird around our shores, the gannet. I remember a holiday in the island of Mull once when our cottage was near the sea and we could sit having our breakfast watching the gannets diving into the water from 30, 40 metres up, because the gannet is a plunge diver. It feeds by diving into the sea at tremendous speed and catching its fish. So the gannet has a whole series of special adaptations to allow it to do that. There's a lovely time-lapse photograph showing how, as it approaches the water, it folds its wings right back until it's almost a perfect streamlined arrow. And it's doing something like 100 kilometres an hour, 70, 80 miles an hour when it hits the water. Now, you know, I'm sure, that if you hit the water at that speed, it would be curtains. So the gannet has quite a number of special features to allow it to do that. First of all, because of its large wingspan, it's a superb glider. It has binocular vision so that it can see the fish, the target that it's going for. As you can see, it's extremely streamlined. Just before it enters the water, protective membranes close over the eyes to protect them. The gannet's nostrils are within its mouth, inside the bill, so that it doesn't get a whack of water up its nose as it hits the surface. Think about that one. The jaws, as it hits the water, the jaws close hermetically so that no water can get into its mouth. It has a whole array of air sacs around its shoulders and breast to absorb the impact of hitting the water at that speed. It can actually go down something like 20 or 30 feet under the water, and it can swim underwater chasing the fish which it's seen from above. And it has a reinforced bill. Now, you could argue that any one of those features could have come about by random chance, I dare say. Just a chance mutation produced a stronger bill. But that's no good, is it? You have to have all of those things, or no. I mean, any one of them would be useless without all the others. And that's an argument which seems to me to cover a lot of these examples, that it doesn't work if you have slow accumulation of features over a long period of time. And so, to me, that says that someone has thought all this out. Said, now what does a plunge-feeding bird need? It needs this, this, this and this, and has designed it. And of course it's all encoded in the DNA of the bird. Now here's another example, an amazing creature called the cuttlefish. If you go to the Sea World in Birmingham, you can see these things, amazing things. It's related to the octopus. It's got 8 tentacles at the front, and it's got a sharp beaked mouth underneath. But it's not a fish at all, it's a mollusk. Have you ever seen cuttle bones on the shore? Bird fanciers keep them, if you keep budgerigars, you hang them in the cage because the birds peck them to get calcium. Now, if you'll excuse, I'm just going to quote from the New Scientist article from which I learned this. It began with the words, "Isn't evolution a bitch?" This mollusk, most mollusks have a strong outer shell, which is their defence. This mollusk was swimming around in the Jurassic Sea, the nice warm Jurassic Sea, and a chance genetic fluctuation, that's the word we use, turned it inside out. So that now, instead of the protective shield being on the outside, it was on the inside, thus making the cuttlefish a tasty morsel for any passing predator. So how did the cuttlefish react? It reacted by developing a unique form of camouflage. And you can see the stripy back. That's just one of thousands of different shapes and colours that the cuttlefish can produce, almost instantaneously. Well, that's fine. So this evolved. How long would you say it would take to evolve this sort of amazing? I'll show you the structure of the skin in a moment. And in the meantime, how did it survive? Because it was a tasty morsel for any passing predator. You see, evolutionists don't answer these sorts of detailed questions. The skin and the colour is wired directly into the cuttlefish's brain, so it can just instantly change its colour and pattern. And it can blend into the background, it can camouflage itself and make itself invisible in just a couple of seconds. And it uses this to avoid predators, as we said. It uses it to confuse its prey. It uses it for mating displays. And they've discovered that it really is a sort of language that it's using, changing the pattern and colour to communicate with other cuttlefish. Well, here's a graphic from New Scientist showing the structure. This is a cross-section through the skin, of course very thin, much magnified, and it has 3 layers, each with very specialised cells which allow it to change colour. You can see these have got, you can pull a cover over these coloured cells so they show or they don't. This produces iridescent colours, and this is a reflective layer. So using those, it can change rapidly. Now just watch the picture. There's the cuttlefish merging in with the sea floor, the lumps of whatever this is, coral or something. It not only changes colour, it can change texture, it's raised bumps. Again, you can go onto YouTube and see some lovely videos of this sort of thing happening. So did that happen by chance mutations over thousands or millions of years? And how did this poor cuttlefish, which has lost its protective shell, protect itself over all that time until this camouflage was developed? Now, some of the most amazing examples of intricate behaviour, of course, comes in the insect world. And here's a wonderful example, the fire beetle. Forest fires are in the news at the moment, and the dreadful fires in Australia. Of course, when there's a fire, all animals, birds, insects flee. They get away from the fire, except the fire beetle. The fire beetle heads for the fire. The Latin name is melanophylla, black seeking, black loving. So they head towards the fire. And when they get to the fire, they don't fly into the fire itself, but when they get to fire-damaged trees, they mate on the trees and lay their eggs in the wood of fire-damaged trees. Why? Because the fire destroys the tree's defence mechanisms. Trees are not helpless against insects. They have many chemical defence mechanisms, but they are rendered ineffective by the fire. And so the larvae of the fire beetle can develop and grow and hatch inside the tree that's been damaged by fire. Now, these are quite a small beetle. Some years ago, there was a fire on an oil refinery in California, and clouds of fire beetles turned up, and the nearest forest was 50 miles away. So it's assumed that the beetles were fooled into thinking that there was a forest fire and headed towards the refinery. So they can detect flames and fire over huge distances. How do they do it? Well, they have two detection systems. Firstly, they have smoke detectors. Their antennae have cells which respond to products of fire smoke. This is one of them. Guaiacol is a chemical produced in pine smoke, and they can detect that. So downwind, they could detect that over huge distances. But more important than that is they have infrared detectors. Now, here's a picture of the beetle flying, and you notice that, of course, insects have 6 legs, and the middle pair of legs are stuck up in the air. That's because in the pits, under the legs, are these pit organs which detect heat. Here's a sort of enlarged picture of the pit organ. And it's got 70 of these little spheres which react to infrared radiation, heat. And in fact, they are tuned to a wavelength of 3 micrometers, right in the middle of the infrared spectrum. So when there's a flaming fire, this radiation, which you can see in the picture, the red, is picked up by the beetles. Because they've got pits under both arms, they can steer towards the heat, because if they turn away, then there'll be more radiation this side than this side, and vice versa. So they can steer towards the fire. And here's one of these spheres. The heat presumably increases the pressure, which presses on the nerve system. And then in the beetle's tiny brain, we just casually say, well, it senses the heat, but it knows that that's where it's got to go to mate. I put all that together. It's an incredible system, isn't it? Absolutely amazing. Scientists are interested in these infrared detectors because, the military in particular want infrared vision goggles and so on to see at night. Again, to me, that says someone has thought the whole system out. Now, at the very basis of all life is this chemical process known as photosynthesis, back to GCSE biology. Wherever you look, there are green plants, and they are capturing the light from the sun, turning it into the chemicals of life, and producing oxygen, which keeps the oxygen content of our atmosphere up that we all breathe. So all life depends on that one chemical. It's not one chemical reaction, it's a whole suite of chemical reactions, but that process. And it surprised me to learn that quite recently scientists still do not know all the details of how photosynthesis works. It's extremely complex. But if we home in on a leaf, here's a leaf with the surfaces, the epidermis, and within the leaf are these structures known as chloroplasts. This is a very quick summary. And within the chloroplast, with its membranes, are this thylakoid membrane, which is attached to strings of the material we all know about, chlorophyll. So here's the chlorophyll in the chloroplast, and this is a blow-up of just part of what chlorophyll does, which is to split water into oxygen, which goes out into the atmosphere, and hydrogen ions and electrons, which go away and convert carbon dioxide. They absorb carbon dioxide from the atmosphere and turn that into sugars, starch, the materials of life, and lots of other chemicals as well. So science has been studying this very complicated process because they would love to be able to do that. Just take the light from the sun and produce hydrogen. Hydrogen is the ultimate fuel, isn't it? No pollution, just goes back to water when it burns, could drive all our cars, our power stations. If man could do that, and yet it's happening all around us, all the time. Nature has designed photosynthesis, or has it? How did it come about? And they've discovered right at the heart of the process, this business of how do you split water. You can do it with electricity. Electrolysis splits water into hydrogen and oxygen. It takes a load of energy to do it. You have to use more energy than you get back. But this does it without using energy, in a continuous cyclic process. And they found this complex molecule. It's actually a distorted cube with 3 atoms of manganese. Now, no, I won't ask you to put your hand up if you've never heard of manganese. That would be demeaning. But I guess a lot of you perhaps don't know about manganese and didn't know that your life depends on manganese. Photosynthesis wouldn't happen without it, the element manganese. So there you have 3 atoms of manganese here, 4 atoms of oxygen and 1 of calcium. And 1 atom of manganese sticking out the side. That was the big surprise. And the energy imparted to that manganese ion is able to split the first molecule of water, and that lends enough energy to the calcium atom to split the second molecule of water. So that they're getting close to beginning to understand how this incredible process works. Well, is this nature's invention? Or is it intelligent design? If the world's cleverest chemists can still not actually work out the whole thing and know how to make it happen in the laboratory for free, how can we say that it could just have come about by chance? And so we come to the eye. It's the classic creationist challenge, isn't it? Even Darwin recognised the eye was a problem, and he came up with a suggested sequence of how it could have developed. Primitive creatures like jellyfish don't have eyes, they just have light-sensitive patches which give them advantage. If a predator comes over, it would create a shadow and they would know something's happening. Some marine animals have more complex eyes which are actually shaped, so you start to get an idea of focus. And then going on to, say, marine snails, they have a lensed eye. So you can build up an imaginary, it is only imaginary because it's a story of how the eye could have developed by stages. There's no evidence that marine limpets evolved from jellyfish or snails from limpets. But you can build up a sequence like that. And Dawkins uses exactly the same argument in The Blind Watchmaker. But the biochemist Michael Behe, some of you may have heard of, in his book Darwin's Black Box, how do these things work? How does the actual biochemistry of vision work? And it turns out the biochemistry, how that light-sensitive patch works, is very complex indeed. And again, we're into very complex chemistry. It all starts with a chemical molecule called retinal. When a light photon hits it, it changes shape, absorbs energy and changes shape. There you see the light hitting it. And that forces the change in shape of a molecule called rhodopsin, which is the basic protein involved in vision. It's connected with vitamin A. That's why you eat your carrots to keep your eyes in good shape. When rhodopsin changes shape, it then sticks to another molecule, another protein called transducin, which responds by releasing a molecule that's attached to it called GDP and binding to another one called GTP. You're getting the picture. It's not anything simple. And the whole of that complex, rhodopsin, transducin, GTP, now binds to a molecule called phosphodiesterase. And when it does that, it cuts another molecule called cGMP and activates an ion channel. That means it opens a hole in a membrane so that an ion can go through carrying electric charge. And that's you starting to get towards producing an electric signal that's going to go up the optic nerve to the brain. Do you see how incredibly all this is happening in your eyes as you're watching this in millionths of a second? And all those signals from all those cells in your retina are being put together, I mean, even more amazingly, by different parts of your brain to build up the picture that you see. I mean, we all know that the image on the retina is upside down, isn't it? The brain turns it the right way up. And when all that's happened, then another series of chemical reactions takes place to restore the cell in the retina, you know, the rods and cones, to restore it to its original state so that it can all happen again. And it happens so quickly that you don't see the break as it resets. The psalmist said, "You formed my inward parts. You covered me in my mother's womb. I will praise you, for I am fearfully and wonderfully made." There is a chemist cleverer than all the chemists in the universities of the world who has, to our belief, designed all these things. In the Gospel of John, we have the wonderful story of the healing of a man born blind. John doesn't actually tell us why the man was blind. We don't know if his eye structures were defective or his optic nerve wasn't connected or there was something wrong with his brain. But I'm sure many of you will know the story where Jesus just made some clay with spittle and wiped it on the man's eyes, said, "Go and wash in the pool of Siloam." Interestingly, just a few years ago, archaeologists discovered the pool of Siloam in Jerusalem. You can go and see it now, the place where that man went and washed his eyes and came seeing. You know, it's just a miracle of healing. His eyes could see. But think of all the things that were happening. All this is switched on. And his brain, which had never seen, which didn't know what vision was instantly reprogrammed to understand what he was seeing. Do you believe it? Or is it just one of those myths, you know, a nice story about Jesus? Interestingly, go home and read John chapter 9. I won't do it now because I'm already over my time as usual. But in John chapter 9, the Jewish council, probably a subcommittee of the Jewish Sanhedrin, conducted a rigorous legal study of this man's claim to see if his claim was true and who had done it and how. So they got the man's parents. Said, "You say you were born blind? How do we know that?" Get his parents. "Was he born blind?" "Yes, he was born blind." "Well, how can he see then?" "We don't know. He's of age, you ask him." They were scared to endorse too much. And you see, there we have a detailed record confirming that this miracle really took place. And just how wonderful that was, I hope you've just seen. So it all comes down to this, doesn't it? This is the pinnacle of modern science, since Watson and Crick in Cambridge in the 1950s discovered the structure of DNA, this amazing double helix, which carries the pattern of everything, of every form of life on Earth virtually, from bacteria to fish, to birds, to humans, plants, all of us, we all use the same structure. So we must have all developed from the same thing then. You see, the argument of common origin suggests that everything has evolved because it all is based on the same fundamental structures, or because the same person designed it all. Why design a different method for each form of life? And so we have this amazing double helix which carries the information in the form of a code with 4 base units which team up with one another, always guanine with cytosine and thymine with adenine. But the order of them along the chain codes for the production of proteins. I'll show you what a protein looks like in a moment. And so it's been called a biological computer. In fact, some scientists have been looking at using DNA as a computing tool. And basically it stores information. All the information to make you is encoded in almost every single cell of your body. There's a strand of DNA which got all the pattern on it. So you could take, well, you know they do this sort of incredible things. They take one cell and culture it and produce a cluster of cells which have got your pattern in it, or whoever it is. There's information there. And information demands an origin. Where does information come from? If you get information in the form of a book, somebody's written it and printed it. If you get it off the internet, somebody's put it there. Information doesn't arise from nowhere, from nothing, from random chance. And so, to us and to many people, DNA is too wonderful, too amazing to be the result of chance. Now here's a quote from the man who I'm using his tools here. PowerPoint is a Microsoft product. Bill Gates, richest man in the world, founder of Microsoft. And here he is saying, DNA is cleverer than by far than any software we've ever written. And more than that, it's got many of the features of human software. You know. It's got auto-correction. DNA has little enzymes that buzz along it, correcting mistakes. That's awkward, isn't it? Because mutations, which are the fuel of evolution, are mistakes. And DNA is trying to stop mistakes. So how do they get through? Some do, of course. Mutations do happen. People get genetic diseases due to a mutation. But they're always harmful, aren't they? You know, scientists are trying to find out how to correct genetic mutations which cause disease. This is what proteins look like. I mean, these are incredibly complex molecules with thousands of atoms. And they work by folding in very specific ways. And many proteins have special jobs. Well, they all have special jobs. Some have more than one job. Many of them are called enzymes, which enable chemical reactions to take place because they've got specially shaped receptacles in them which allow molecules to come in, join up and float away again. So that's what DNA is producing. Now, if you took all the DNA in one of your cells and stretched it out, it would be 2 meters long. Extremely thin, far thinner than a human hair, but 2 meters long. How does it get inside your cell, which you can only see with a powerful microscope? And it's all down to the way it's folded up. It's sections of DNA are folded around these structures called, here we are, nucleosomes, and they have tails called histones, which control how genes switch on and off. And then all of that is packed up and rolled up into this, which is called chromatin. And chromatin is then folded up into the chromosomes, which you can see with a powerful microscope inside the nucleus of the cell. I mean, it's just staggering, isn't it? The complexity of it. And when you want to make a protein, a bit of this has to open up so that you expose the length of DNA that's going to do it. So an enzyme causes that to happen. And then along comes a chemical called RNA, not DNA, but RNA, and copies the length of DNA and takes it away and assembles all the bits to make a protein, and the protein floats off, and it's all folded up again and goes back into its... To me, to believe that all this could have come about by nature, by chance, is far more difficult to believe than that there is a supreme being who has designed these things. And one of the most notable atheists of the last 50 years came to the same conclusion. And Professor Anthony Flew died a couple of years ago, produced papers on the justification of atheism, which became the standard text for atheists. And then when he looked into DNA, he said, I cannot believe it any longer. I can't claim that he ended up believing in the God of the Bible, but he certainly ended up believing in a supreme intelligence. Intelligence must have been involved in bringing all these things together. So one atheist was convinced. Well, just the last example, it has become a sort of icon of the intelligent design movement, the black bacterial flagellum, which is a molecular propeller by which bacteria swim. Bacteria, the simplest creatures, just a single cell, and they grow these little tails that spin around at 70, 80,000 revolutions a minute and propel them along. And this is the wall of a cell, and here's it just looks like an electric motor inside. It's got a stator, a fixed part, and a rotor which is spinning round, driving this shaft. And it's got a bush which prevents liquids from inside the cell floating out, so it seals itself. Now, it's a very impressive molecular motor. But evolutionists have come back and said it's something like 50 different proteins are used by the cell in building that. Evolutionists have come back and said, we found out. They've discovered another structure. You can look it up on the internet. It's called the type 3 secretion system, because some bacteria, the nasty ones like Salmonella and Shigella, they produce nasty poison toxins, virulence factors, which go up a similar pipe through a bush in the wall of the cell and invade other cells and poison them. And 10 of the proteins in the flagellum are used in this structure. So they say, there you are, those 10 proteins, they're used in 2 different jobs. So the flagellum could have evolved from this sort of structure. Well, I don't see that at all. If I was designing 2 different things for 2 different purposes, and they both had to go through the wall of the cell, well, I'd just use the same solution for both, wouldn't you? Where's the logic in having a different system for this, a different system for me? So, to me, it's not made any great difference. We're on to number 3. Yeah. This is a computer graphic produced by the University of Kyoto, I think it is, showing how this structure is built. But each of those different coloured pieces is a different protein. And here's the motor being assembled inside the cell. And now a cap is produced which is going to break through the cell wall. Here's the cap. It's going to push through the cell wall, make a hole, and immediately seal it with these bushes. And then it's finished with, it floats away and a new cap forms, which is going to produce the universal joint. So each of these is a protein unit, which is bound together in this strand. That's finished with. Now it's going to build the tail, the flagellum itself. Here comes, you notice all these proteins are coming up from inside the cell. And now, very cleverly, this has got little arms which direct each successive protein unit in a spiral. Each one comes into place. And eventually it completes the whole tail. Just think about how this could come into being. Whether this could have taken place by a series of small changes over thousands, millions of years, or whether it was designed for a purpose. So there's the flagellum. Most bacteria have 3 or 4 of them. And it swims off into your bio yogurt you're going to have for breakfast tomorrow. The medieval philosophers talked about God's book of nature. There's the revealed book, the Bible, and there's the book of nature. And both of them speak of the handiwork of God. And so Job says, just look at the living world. Look at the incredible complexity of it. Look at the wonder of it. And as I said at the beginning, we're a privileged generation. We've seen so many amazing things. That the hand of the Lord has done all this. Now just very briefly, well, yeah, I meant to end with the resurrection, because resurrection is a creation miracle, isn't it? Jesus was only dead for 3 days. Lazarus, his last miracle, had been dead for 4 days. And his sister protested when they opened the tomb, Lord, by now he'll stink. Corruption would have taken place, and resurrection was an instantaneous recreation of that person. And the witnesses to the resurrection of Jesus tell us that it really did happen. And so Jesus, Paul tells us, is the first fruits from the dead. This is the Christian hope. That when he comes again, he will raise the dead. They will be recreated. God doesn't need millions of years to develop man. He can make him instantaneously. Now, we have to admit that creationists, as we are divided as to whether the earth is young or old, whether creation took place literally 6,000 years ago or much longer. I mentioned before that the mainstream churches have taken the position of accepting evolution but saying, well, God is behind it. But how do you marry the idea of a creator God with purpose with a chance process which has no purpose? That's the difficulty I find. That's the thing that I can't bridge. To me, you can only have one or the other. And so we have evolution, but because evolution is always presented in the media, on TV, as the fact, the truth, it's there, all scientists accept it. And most scientists do accept it, but they don't agree on how it works or how it's happened. There's a lovely quote by Simon Conway Morris, who's a theistic evolutionist at Cambridge University. He writes on evolution. He says the only thing that evolutionists agree on is that it happens. Because there are competing versions. There's the classical neo-Darwinism that Dawkins espouses, that we've talked about. But others, particularly in America, Eldridge and Jay Gould, have said the fossil record just doesn't tie up with the gradual accumulation of changes. What we see in the fossil record is long periods of stasis when nothing changes, and then sudden periods of evolution over very short periods, which sounds remarkably like creation, like miracle, really. But so the interesting thing, this book, The Darwin Wars, by Andrew Brown, is about the relationships between the people who say they hate each other, they fight each other, they pour scorn on each other. So evolution is not a sealed deal. It's just a collection of people with one idea. And some of the great, particularly in France, there's a great French zoologist, Pierre Grasset, who wrote a 30-volume description of life on Earth and was one of the world experts on insects and particularly termites. And he wouldn't accept either of them. He said there must be some other principle of evolution which we haven't discovered yet. So there you have it. What does God say? This is what he said to Job again. Where were you when I laid the foundations of the earth? Tell me if you have understanding. And that seems to me as a challenge. None of us can answer that question. None of us were here. No one was there. We can speculate on how God did it, when he did it. But you know, the important thing is that purpose that God had when he designed it all. The important thing is not the past, but the future. Because God has promised a wonderful earth. And evolution can say nothing about the future, can it? By definition, it's a process which has no knowledge of the future. It has no purpose, it's not going anywhere. Change will take place, but we don't know what that change will be. Have you heard David Attenborough's forthcoming series? He will propose that evolution has stopped because man has now taken over. Man can control his own evolution, birth control, even they prevent the birth of girls if they want boys and awful things like that. Man can control what happens. They can stop genetic diseases being born. And on the other hand, there are people who say, no, it's happening faster than ever. Man is, all the changes in the earth, global warming is driving evolution. So evolutionists are divided even over that. And evolution can't tell us whether there will be a mass extinction, as a claim was in the past when the dinosaurs were made extinct. Who knows? It's all a mystery. But with the knowledge of God's purpose in the Bible, what God has done in the past and what he has said he will do in the future, then he has promised that the earth which he made to be filled with his glory will be a paradise for those who are raised from the dead and invited to share the glorious future with the Lord Jesus Christ when he comes again. So, thank you very much for your patience as I've gone on, as I said, much too long. But I hope that you will at least have something to think about the challenge of design in the world, and share with us the understanding, the belief that what God has said he will do in the future will truly come to pass. Thank you.